I'm here today to talk about ocean and coastal acidification and industry perspective, and I want to emphasize an industry. It's not the industry. And I'm going to try to keep the chemistry to a minimum, but I want to start with the fact that about 25% of the carbon dioxide from fossil fuel dissolves in the world's ocean, forms carbonic acid, and the result has been a 30% increase in the surface water acidity since the dawn of the industrial age. The rate of change is accelerating as carbon emissions increase, and by 2100, it's forecasted that ocean acidity will have doubled. The rate of change may be unprecedented in the Earth's history, and if we were just talking about this global phenomenon, which is what I just described, I probably wouldn't be here. But what happens when you get near shore is that there are a number of exacerbating factors. And one of the chief factors, and this is another sort of untalked about consequence of climate change, is the fact that if you look at this chart, and actually that 67% in the upper right for the Northeast is, I believe, a low estimate. I think that's up now to like over 70%. But essentially, this just shows the percent increase in what they define as very heavy precipitation, which is the top 1% of precipitation events. And you can see that the Northeast is kind of the bullseye for this. The problem with that is that this increasing freshwater runoff is acidic, more acidic than the seawater that it's running into. And a lot of the water that's coming in is poorly buffered, and this creates an enormous amount of variability in these nearshore coastal waters. You've seen this slide before. The other exacerbating factor is that this Nova Scotia current, which does contain a lot of meltwater from the Arctic and coming out of the St. Lawrence River, is relatively fresh. So we have basically runoff from land, which is increasing, and this Nova Scotia current, the contribution into the Gulf of Maine, has also been increasing, kind of on a decadal scale. In other areas, for example, in the Pacific Northwest, you can have other local effects that exacerbate acidification. The oyster industry nearly collapsed a number of years ago due to an increase in prevalence of northerly winds, which blew water offshore, and there was a much more acidic water that was coming up and replacing that surface water, and it caused a near collapse of the Pacific Northwest oyster industry. A little more chemistry. This kind of explains why the initial focus in ocean acidification, the effect on ecosystems and species, was focused on shellfish. And essentially what happens when carbon dioxide is dissolved in water, you form carbonic acid. And the big take-home message here is, if you look in the lower left, as the partial pressure of carbon dioxide increases in the water, as you dissolve more carbon dioxide in the water, it goes to the right, the amount of carbonate ion, which is on the horizontal axis, is less and less available. I'm sorry, I got this backwards. Carbonate's on the left. As the concentration increases of carbon dioxide on the lower axis, you have a drop in concentration of carbonate ions. That's so critical because every organism, a marine organism that makes a shell, a calcareous shell, needs calcium carbonate. That's what they're making it out of. And the thing about this is it's an incredibly new area of scientific inquiry. Most of these studies that I'm summarizing here have only been done in the last 10 years. And to kind of summarize these, we have a lot of recent studies that show that acidification hurts bivalves, and that larvae are most vulnerable. And the reason for this with shellfish larvae is that they make their shells out of the most soluble form of calcium carbonate. It's called aragonite. And I'll talk about that a little bit later. But for both larvae and juveniles, the negative effects can be additive or synergistic with other climatic change stressors. And that's going to be the big thing going into the future. It's not just this happening by itself. It's the fact that you also have temperature increases, you have increasing anoxia, and those are the things acting together that can be real problematic. It's not just, now we're discovering that it's not just affecting shellfish, that they're making calcium shells, but also cod, summer flounder, Atlantic silversides, and even clownfish. There have been studies showing effects on them that are not positive effects. We're largely ignorant about ocean acidification impacts on lobsters, and I'll talk a little bit more about that later. But that, to me, I'm just amazed by that, because when you see the importance to the Maine economy, that's a serious oversight. And we're pretty clueless overall about how ecosystems will change as the pH drops, as the water becomes more acidic. So meanwhile, getting back to why I'm here, all of this was going on, and I'm trying to figure out why our oyster larvae are having problems. We were seeing, in some cases, poor egg conversion. We'd fertilize the eggs, and the survival after the first 24 hours could be very low, or in a lot of mutations and things like that. They're really weird-looking larvae. But more often, we would see a cessation of feeding, poor growth, and protracted larval phases. And this seemed to be tied in very closely to large storm events. So for a variety of reasons I won't go into now, but you can ask me about later, we assumed that carbonate chemistry was the problem. We developed a whole suite of management and mitigation tactics within the hatchery where we can control the conditions. And this year, these were applied very consistently to every single spawn that we did. And for the first time ever, we did 16 spawns, and every single one of those spawns developed normally. And I want to explain that a little more. When you fertilize an oyster egg, within 24 hours, it forms this very fragile shell, and then it grows over the next 14 days or so to the point where it goes through a metamorphosis, moving from a planktonic veliger, it's called, to a bottom-dwelling post-set oyster. That process, in the hatchery, we are able to consistently do that in 14 to 16 days, and that was the difference. By making these modifications to how we handled our water, there are a whole suite of them, some of which are kind of proprietary, but the point is that they all made the assumption that it was carbonate chemistry at the root of these big delays. To give you a little idea of why we were so interested in doing this, each one of the spawns that we do is typically worth and this is not market oyster, this is just small baby oyster seed sales, over $100,000. So if during the course of a spawning season, which runs from basically January into the end of May, if we have 2 spawns that take an extra week, which is what we would see, we lose a spawn. That's a fair amount of money. So the take-home message is that through observation, trial and error, and a lot of heartburn, we were able to reach the same conclusion that scientists doing controlled, replicated experiments came up with. Acidification is not a future problem. It's here and it's happening now. And I guess you're probably not, people aren't too interested in just what's happening in a private business, but the fundamental question that all of this raises is what's happening to natural populations. And I had another slide in here which I took out, so I tried to keep it within 20 minutes. But we have been doing some water quality monitoring, measuring various parameters over the last number of years. In fact, this last April, we installed a very sophisticated continuous PCO2 monitoring device in our incoming water. And these are some of the results that we've gotten. The first, an upper graph, were collected using a fairly inexpensive pH meter and a salinometer, and we were measuring temperature and so forth. And those, and we calculated, and the red is what I want to talk about. This gets back to that form of calcium carbonate called aragonite. One of the things it turns out is very critical for, especially in that first 24 hours, for larvae to be able to develop their shells, is this, it's called the omega aragonite, and that's, it's a measure of the saturation of calcium carbonate in the form of aragonite in the water. And through all of that benchtop research, it's been determined that there's a magic level, which they believe is about 1.6. And if the saturation level is below 1.6, the larvae are going to have a really hard time. If it's above 1.6, they're going to do okay. Well, the point here is that whether you're looking at data collected by fairly inexpensive and maybe subject to some inaccuracy versus a more precise high-tech measure, the results are very similar in that we very rarely are over 1.6 in our incoming water. So that raises the question of, well, what happens to wild populations? We can change our water quality in a hatchery. That isn't, a spawning clam can't do that. Soft-shell clam, for example. So, and here is where what my prediction is regarding the effect on shellfish resources. Based on what I've seen and what I've read, I believe that what we will see is failing recruitment of young oysters, soft-shell clams or mussels or whatever, or scallops. That it's going to be the larvae that are most dramatically affected, and what you will see is more variability in spawning success. And my prediction is also that that will coincide with rainfall events. So, for example, if a soft-shell clam population is ripe and they broadcast their gametes into the water and you get fertilized eggs, if then you get a 3-inch rain event, those larvae are not going to do very well. And so I asked myself, well, is there any evidence that this is beginning to happen anywhere? And well, there is. Oyster spat collection in New Brunswick, that's the way. They don't have hatcheries there. They collect all of their oyster spat, with these collectors. There are, thousands of acres of them up there in the Northumberland Strait. And we've had Canadian shellfish growers coming through our hatchery wanting to know all of our secrets for running a shellfish hatchery because they want to build their own. They had 2 years in 2 different places where they had spat fall failures, and that caused them quite a bit of heartburn. Those are the collectors. Looking at them up close, you can see the darker brown. Those are all little baby oysters that have grown on those collectors. There's also some evidence of mussel spat fall failure. I used to own a mussel farm on the Damariscotta River, and I was talking to the fellow who owns it now, and he was saying that when I owned it back in the 90s, there was a much more predictable recruitment of young seed to the seed lines. We could basically count on a spring set, and then most often we would get a fall one as well. That's become much more sporadic now. So what's at stake? And I was going to show this as a table, but I didn't because it's quite dramatic, shown as this bar graph. First off, I want to start at the bottom, that just the landed value without multipliers. So you can multiply that, I would guess, by at least 3. There may be economists in here who would know better. But I know my oysters wholesale for about 50 cents, and I know that you can't buy them in a raw bar in New York for much less than a couple bucks. So, and I'm assuming that's true for a lot of these other species. So, the total value is about 476 million. The calcifiers are a little over 400 million, which represents 87% of the total. So there's some vulnerability here in Maine. Furthermore, I find this the importance of lobster to be very scary, because we don't even know what the effects of this will be on lobsters, or is, currently. So that's one of the things that I think needs to be really delved into. So what's going on? What are we doing about all this? So I can tell you what I'm doing. I participate in this outfit called NECAN. And it stands for the Northeast Coastal Acidification Network. It's a group of scientists, people from NOAA. I'm the only industry person on it currently. I'm hoping to recruit some more. And also a variety of extension type people, and I think there's actually somebody from a nonprofit as well. And these are, our mission really is to review and assess the most recent scientific information and try to get stakeholder input and questions so that we're attentive to that. And then the idea is to synthesize all this and basically communicate what the critical knowledge gaps to the important state and federal agencies, help to set regional priorities for monitoring, modeling, and research. This is sort of the process we've been going through. There's a wonderful webinar series of expert scientists in their fields have given a whole series. I think there's 16 webinars that took place from November 2013 through March of 2014. Those are all available on the NERCUS website. From those webinars, then there was what we called the State of the Science meeting, which was held down in New Hampshire. We got all these people together, everybody we could, and sort of made up basically what's going to come out of that is an article that will be a review article in the Journal of Oceanography, and then also some technical documents that will provide one place where you can go get a current state of the science. The next step, as we're in the process, that second part there, then that will be hopefully translated to common language so everybody can understand what we're talking about. And then there will be some workshops where we seek stakeholder input and come up with ways that we can start beginning to deal with this, and that would be the implementation plan. I'm also serving on the State of Maine Commission to study the effects of coastal and ocean acidification. And it's a really kind of exciting group to be with. There's some very, very sharp people on this. A couple chemical oceanographers, a bunch of biologists who really know their stuff. And it's always exciting to see the level of expertise that we have right here in the state of Maine. Senator Chris Johnson and Mick Devon are the co-chairs. And you can see the representation there. There's from state government, industry, academia, and environmental groups. And these are the charges that are laid out in the legislation to identify the factors contributing to acidification, how to mitigate acidification, critical scientific data and knowledge gaps. So, for example, this is an area where NECAN will hopefully provide a lot of information to the Commission. In fact, it already has. And then what are the steps that we need to strengthen monitoring, research, and analysis, and recommendations to the legislature and steps needed to increase public awareness. So all of this comes down to how do we go about lessening the negative impacts of acidification and take advantage of the economic opportunities. And the first thing I think we need to do, and everybody on the various groups that I participate with agree with this, is that we need to understand the chemical oceanography, which was talked about a little. It's very complex, believe me, and I'm struggling to understand it myself. But that is really the first step, and that is going to take a dramatic expansion of monitoring. The second part of that is to understand how ecosystems are going to be responding, as well as the species that live within those. The charge for the Maine Commission is really to focus on commercially valuable species, but I think NECAN isn't constrained by that so much. So hopefully there will be recommendations for how we move forward with looking at ecosystem consequences. And then finally, also as a business person, I think this is probably unrealistic, but what I would really like is to have a predictive set of models. So if I'm considering certain types of investment, I can know whether it's a good idea or not. Right now, it's become less of a calculated risk and more of a gamble when I consider doing certain capital investments. So whether you could develop models that would be accurate enough to allow that kind of decision making, I'm a little skeptical, but I'm hopeful. And then, of course, we then, taking all of this, we need to figure out ways to mitigate and adapt. And there I have a picture of a kelp farm in China. It gives you an idea of the scale they do things over there. I think the Army Corps might have a few problems with this here in Maine. But the point is that seaweed, would be one thing that you would want to look at, because plants are taking the carbon dioxide out of the water, and therefore helping to solve that problem, at least on a limited local basis. There may be issues with whether they're taking the nutrients out of the water that my oysters would, that would allow the phytoplankton to grow, and therefore might negatively affect oyster feeding. I would want to look at that very carefully before they put a big one at the mouth of the Damascus River. So we can mitigate, adapt, and model and do all that stuff till the cows come home, but it's not going to do anything. I mean, ultimately, we need to reduce greenhouse gas emissions. And maybe people here who work for the government can't make this case, but I'm here as a private business person, I'm going to. There are a lot of people who say we shouldn't take action because the effects of greenhouse gases aren't clear. Well, my response to that is tell that to the residents of these South Pacific islands who've already moved from one island to another because of sea level rise. And there are a lot of South Pacific islands that right now are being threatened. It's not a future problem. Talk to East Coast homeowners and planners coping with river flooding, rising storm surge, and sea level, or South Florida residents whose wells are now saline. I attended a hearing in Washington, D.C., and a woman from Broward County, who was a county commissioner, showed a map of that southern part of Florida with a red line. To the east of that red line, all of the wells it had saltwater intrusion and were worthless. And it was a huge area. It's a massive problem with massive infrastructure costs that are looming. And then I already mentioned, West Coast oyster growers who nearly went out of business. This was a huge problem, and they did take a lot of action. And because most of the oyster production out there is hatchery-based, they've been able to come up with strategies to allow production to continue, but it doesn't take away the underlying problem that is facing the natural sets of oysters out there. And then, I would like these people who say that we shouldn't take action explain why, when Maine lobstermen and clammers lose their livelihoods, they should come to the Maine Fishermen's Forum and express that viewpoint. The point is that taking no action, in my opinion, is a huge gamble, considering how little we know about what's happening in our coastal waters. And most of the people who say we shouldn't take action are really not looking at the oceans. And I think that's a huge, huge question mark, is what is going to happen with climate change and how it affects marine resources and livelihoods and all the rest of it. The other argument you hear is that curbing greenhouse gases will be too costly and slow down the economy. Well, I just don't think history supports that. If you look at the Clean Water Act, lots of doom and gloom were predicted. That never happened. The Montreal Protocol, everybody thought that was going to have a huge economic impact. We switched from underarm spray to deodorant sticks in an eye blink with no economic downturn. And I don't think that you can do, and actually I missed a few check marks under here, but there's no major transformation in civilization that's occurred. And I believe switching from a carbon-based economy to renewable energy is analogous to the, it's similar to the Industrial Revolution or any of these other revolutions. You just can't really say that there was an economic downturn as a result of those things. Certainly when we switched from horses to automobiles, I don't think the economy took a huge hit. And I think the same is true for the information revolution that occurred after the moonshot and throughout my younger years. And I'm talking as a person who in high school did sport a slide rule. And now I have a phone that has enough information to take you to the moon, right? So I want to end with a formula, and believe me, this is a joke, because I'm no one to be putting complex formulas, but it's a nonlinear equation to solve the carbon emission problem. And L stands for leadership, BR stands for basic research, SME is science and math education, and A is American innovation and ingenuity. And it equals a term that's raised to an exponent of greenhouse gas reduction and unexpected benefits. And I just want to talk a little bit about the terms on the left. And one of the problems we have is that the basic research in science and math education really kind of depend on L. And we are definitely lacking L. And that brings me to the Bob Dylan song, because I've concluded that the answers to these huge global problems are not going to be coming from our leadership in Washington, D.C. So everybody, some of you probably remember the Bob Dylan song, Blown in the Wind, Changes the Cone. So with that, I'll answer any questions. Hope I didn't offend anybody with the politics.
Thank you, Bill. You know the drill.
I have a question, a comment first. It's going to take a lot of courage to address a lot of these problems that we've said today, we've presented today. It's not, you got to be brave and confront, and if you believe in it, you got to stand up and speak it. And everybody in this room has to do that. Have the courage to address somebody. If you're saying something that's really ignorant, or it's hurting, or it's killing us in a slow death, speak up. One question for you as you went through your program. Has there been documentation how, if we did wean off fossil fuels, how quickly or how slowly it would take to make this change of stop the acidification? I know it's not going to come back right away, but just how has there been documentations of how much change we would and how much of effect we would make?
I don't have a great answer for that. I wish I'd anticipated that a little more, but I do know they're talking generations. So I mean, that's why it's so important to get on this right now, because we really are reaching a point where there's going to be catastrophes. And I mean, just think of, right now, as I said before, let's go back to that lobster fishery a little bit. That is, right now, there's clear effects, happening with temperature, and there's a lot of concern raised to that. But nobody's really looked at what happens when you combine these elevated temperatures with dropping pHs, and it's going to be the combination of these climate change effects that are going to devastate things. But everything I've heard is this is not going to go right away. If we turn the switch today and stop burning coal, we're going to be wrestling with this for a while. So we really have to do and be smart about whatever we do for adaptation and mitigation, preparing communities for different types of economies.
One more.
If we lose the lobster fishery, it'd be like losing 50 of those mills in Bucksville just goes by.
Yeah.
Just imagine.
I'd rather not, but I think we should start imagining it.
Well,
yeah.
That's what I mean about courage. We should start addressing the...
Just to kind of a follow to your first comment, this is the first year that I've actually stood up in front of people and said, yes, we are seeing this happening right now. And it's a result of what we did, in our hatchery over the spring. I felt like, okay, I'm really seeing this, and I feel kind of morally obligated to speak up. And it's not a political issue. The science is settled, no matter what you hear. I mean, these are basic. This dissolution of carbon dioxide into seawater is high school chemistry. The more carbon dioxide in the atmosphere, and that is increasing, and it's increasing at a faster rate, the more dissolves into the water, and it's basic. And I guess going back to the very end of this, if by some miracle we can get this country behind, converting the economy to a renewable energy source, I see that as being an enormous economic advantage for the United States, because I guarantee you other countries are going to be beating a path to our door to buy the technology. And that's what we've always done. If you look back in our history, the history of this country since the Industrial Revolution.
I can answer that question. the acidification we're seeing in the oceans now is the result of carbon dioxide that was pumped into our atmosphere 50 years ago or more. The reason why carbon dioxide is the most worrisome greenhouse gas isn't because it's the most abundant, which it is. It's not the worst greenhouse gas. Methane is a far worse greenhouse gas. It's because it sticks around in our atmosphere for so long. And so why ocean acidification is a huge problem is if it's this bad now, if we turned off the tap today, in 50, 60 years, they're still going to be seeing that increase. And so if we turn off the tap today, it's going to be 150, 200 years before we start to see the result of it. It's that long of a time scale.
Kind of depressing. Thank you.
I did a good degree in this.
I was hoping to end this on a positive
Yeah.
note, but
I think we had one more question.
Has anyone looked at just how much calcium is being extracted and landfilled currently? So in Maine, we shuck a lot of clams. It's treated as a waste product. Lobster shells, same thing. They go into compost. Some go right into the ground. I think it would be great to get a handle on that and then to
I agree.
recycle that back in.
I don't think anybody has. Although one of the things happening in Casco Bay, some of you may be aware of, is there's been an acidification process on the mud flats, and there are certain mud flats that are now where the pHs are so low that the clams don't settle out, the larvae don't settle out on those flats. And there's been work, Mark Green has done a lot of work looking at what happens when you take crushed up clam shells and put them on the surface of the flats, and they in fact do act like it's like giving the mud flats a bunch of Tums, basically, and it works. So there's a lot of rationale. So pretty soon we'll be shipping our oysters out, and it'll be a returnable, right? Bring them back and put them in, shuck them, and question is, I got to figure out how we would get the money for it,
Well, thank you very much, Bill.
You're welcome.